Hello, everyone. Welcome back. So what we're looking at today is 5.1 pet sitters. So let's go ahead and jump right in. So what we have here are solving systems of equations by graphing. So we've seen a little bit with systems of equations already. We're going to look more into those a little more deeply in this chapter. So what we want to take and do is substitute the given points into both equations and determine which ordered pair satisfies the system of linear equations. Graph both equations and label the point of intersection to verify the solution. So the one that we're looking at here is number 1. We have the equation y equals 3x minus 2 and y equals x. So we have these 3 points. If we plug in point A into the first equation, we end up with -2 equals 3 times 0 minus 2. That'll go away. We'd have -2 equals -2. So it works for the first equation, but the second equation, does -2 equal 0? No, so we know it can't be A. Now we look at B. Well, 2 equals 2, that's going to work, but in the other equation, 2 equals 3 times 2 minus 2. 3 times 2 is 6, so we have 2 equals 6 minus 2. 6 minus 2 is 4, not 2, so that one won't work. So it has to work for both equations. So no, you can't just test each one of these points into one equation to see if it works. You have to test it into both of them. You need it to work out in both situations. So for point C in the second equation, we'd have 1 equals 1. We know that's true. Now in the first equation, we'd have 1 equals 3 times 1 minus 2. 3 times 1 is 3, minus 2 is 1, so 1 equals 1. So C is the correct answer here. Now, yes, you do still have to graph this. So to graph this first equation, we start with the y-intercept, which is -2. So we go to the y-axis and we go down 2. There's our first point, our y-intercept. Then we have a slope of 3, so that means we're going to go up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. So we just follow our slope through, 2, 3, over 1. We come back down here, 1, 2, 3, over 1. So that way we have the whole thing graphed out. And so there's our first equation, all graphed out. Now we need to take and graph the second equation. I'm going to try to draw the line through these. Kind of, sort of. So our second equation, y equals x, we start at the origin. So here is our y-intercept. So anytime you have an equation that's just y equals x, it's the same thing as y equals 1x plus 0. So we start at 0. We go up 1 over 1, up 1 over 1, so on and so forth every single time. And so here would be our line. Our point 1, 1 is right there. So we were correct with our algebraic solution and showing it on our graph. So that's key. Your answer over here in the A, B, and C should be where these two lines intersect on the actual graph. So if it doesn't, either you graphed it wrong or you did your algebraic solutions wrong. So be careful. All right. The next thing we're looking at is we're looking at solving the systems of equations by graphing. So here we are only graphing, and systems is your keyword for this lesson. So we're looking at number 4 here. We're going to start with the equation y equals -x. So just like on the last one, that means we're starting at the origin because there is no y-intercept. But this time we have a -1 slope. So we're going to go down 1 and over 1. Down 1 over 1, down 1 over 1, down 1 over 1, so on and so forth. Draw our line through there. Now, for the first equation, we have y equals 3x minus 8. So our y-intercept is -8. So we're going to start down here at -8. So 1, 2, 3, 4, 5, 6, 7, 8. There's our y-intercept. Now we go up 3. 1, 2, 3, and over 1. 1, 2, 3, and over 1. There's our intersection point at 2, -2. Now we go up 1, 2, 3, and over 1. 1, 2, 3, and over 1. And so there is our line and our intersection. So you will need to take and find that point of intersection. All right, determine possible solutions to inequalities. So for these, it's easiest to make tables to try and figure out possible solutions. So the Utah Jazz scored 102 points in a recent game. The team scored some 3-point shots, 2-point shots, and many free throws worth 1 point each. 5 combinations of baskets that would add up to 102 points. So in thinking about this, we know we're going to have various 3-point shots. We're going to have some 2-point shots. We know we're going to have some 1-point shots. And we know we're going to have the total, which on every one of these needs to be 102 for all 5 that we do. So let's say they got 10 3-pointers. That would give us 30 points. So we have 102 minus 30 is going to give us 72 points left. So for our 2-pointers, we could say 30, which would get us 60. So then we'd have 12 points left, which means there'd be 12 1-point shots. So now from there, we can kind of alter it. We can take and do 10 3-pointers. We could do 31 2-pointers and 10 1-pointers to get to our 102. We could do 10 3-pointers, 29 2-pointers, and let's see, so we took that one down, so 14 1-pointers to get to our 102. So I know that's only 3 instead of the 5 combinations, but that's all the more I can fit there. But it's basically just looking for different ways to calculate this out. So we can write equations to do this. We can plug in values and work it out to see what we get. But there's our solution. All right, number 7 is extra credit. You do not have to do it, but if you would like to, you can. It'll get you a couple points extra credit if you complete it, okay? All right. Our next section, we are looking at graphing linear equations and determining if a point is a solution to the equation. Then find 2 points other than the 0.35 that are solutions to the equation. So we're looking at number 11 here. So our y-intercept is 4, so we're going to go up 1, 2, 3, 4. There's a point. That's also a point that is a solution. So 0, 4 is a solution to this. Now, we have a slope of -3, 5. So that means we're going down 3. So 1, 2, 3. And we're going to the right 5. 1, 2, 3, 4, 5. There's another point. So this is 5, 1. And then we'd go down another 3. 1, 2, 3 over 1, 2, 3, 4, 5. There's another point. We can come back here and go up 3, 2, 3 over 5. There's another point. So is the 0.35 on this line? If we go over 3 and up 1, 2, 3, 4, 5, is that point there on the line? No, it's not on the line. But this is our line here. Okay. All right. Our next section, the tables below represent different arithmetic sequences. Fill in the missing numbers, then write the explicit equation. So the one we're going to do together is number 13. So remember, when we're given first and last points in our arithmetic sequence. You're going to take -7 minus -7, oops, not -17, -7 minus 17 over 13 minus 1. So if we take that -7 and subtract 17 from it, we get -24. And 13 minus 1 gives us 12. When we divide this, we get -2. So our equation is y equals -2x plus, remember we have to find the zero term, so we go backwards 1. So it's going to be plus 19. Now, for each of these boxes, we are just subtracting 2. So I'm going to fill that in real quick. 13, 11, 9, 7, 5, 3, 1, -1, -3, and -5. So this is how you solve these. You'll take the last number minus the first number over the term number minus the previous term number. So 7 minus 1 in this case. So notice, this is -7 minus 17. I already did that. So you're going to have -24. So the part you're going to have to change is the 7 minus 1, which is 6. So in this one, you'd be taking -24, dividing it by 4, and that will get you your slope. So for 15 and 16, these are based off of each of the previous questions, so 12, 13, and 14. So you'll answer them based on what you get for those, okay? All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.